The AnyCubic Kobra S1 is a lower cost 3D printer compared to the Bambu Lab P1S. But is it a better value? That's what we're going to find out in this video. Hi, I'm Ken of Wrist Innovations and welcome to today's video comparing everything about the AnyCubic Kobra S1 and the Bambu Lab P1S 3D printers so you can make an informed decision on which one to buy if you are considering these printers. I've organized the video into chapters listed in the description that will allow you to skip around the video depending on what's important to you. I just want to mention that I bought the Bambu Lab P1S printer with my own money. However, I want to thank AnyCubic for sending me the Kobra S1. Okay, let's get started. Comparing parts quality. I printed parts on both the Kobra S1 and the P1S using PLA, PETG, TPU, and ABS. And I think you're going to be surprised at the results. I didn't print any glass-filled materials because the Kobra S1 is not able to print these materials, which I'll go into more details later. Since this is the first time for me to use the Kobra S1, first I printed a preloaded design of a benchy in PLA, which turned out reasonably well. Then I began my printing comparison test for both the Kobra S1 and the P1S printers. I printed a benchy designed by Creative Tools in PLA on both printers. The P1S benchy turned out great, as expected. The Kobra S1 benchy also turned out great, and I really couldn't find any differences between the two parts. Next, I printed this calibration test designed by Gabox 3D on printables using PLA. For the P1S, the overhang test did successfully print all the way to 80 degrees. The various cylinder diameters measured 9.88 millimeters, 7.83 millimeters, 5.79 millimeters, and 3.78 millimeters versus design diameters of 10 millimeters, 8 millimeters, 6 millimeters, and 4 millimeters respectively. The various rectangle lengths measured 10.00 millimeters, 19.96 millimeters, and 30.04 millimeters for design lengths of 10 millimeters, 20 millimeters, and 30 millimeters respectively. Bridging overall looked good, and there were only a few stringers on the part. For the Kobra S1, the overhang test also successfully printed all the way to 80 degrees. The various cylinder diameters measured 9.79 millimeters, 7.75 millimeters, 5.80 millimeters, and 3.74 millimeters versus design diameters of 10 millimeters, 8 millimeters, 6 millimeters, and 4 millimeters respectively. The various rectangle lengths measured 10.00 millimeters, 19.96 millimeters, and 29.89 millimeters for design lengths of 10 millimeters, 20 millimeters, and 30 millimeters respectively. Bridging overall looked good, and there were little to no stringers on the Kobra S1 part. Overall, I consider both calibration parts to be essentially the same quality and accuracy. If you need to print a part and you don't have a 3D printer, you can do that through the sponsor of today's video, PCBWay. You can go to PCBWay's website, upload your STL file, and they can make it and ship it right to your door. They have several 3D printing capabilities including FDM, SLA, and SLS. PCBWay can also provide PCBs and PCB assemblies, CNC machining, sheet metal fabrication, and injection molding. I have personally used their services to 3D print a stainless steel insert for a high wear application. Their customer service and quality of parts are excellent. There is a link in the description below, and they will even provide you with a $5 welcome bonus. Thank you, PCBWay, for sponsoring today's video. Now, back to the show. Next, I printed this spiral vase design using PETG that was uploaded to printables by Max 41349. However, the original design is by Big Bad Bison on Thingiverse.com. The P1S part turned out beautiful. I really couldn't find any defects on this part. The Kobra S1 part turned out well overall, but it did have some more random defects, and it had some strange thick strands of filament inside the vase. Overall, the P1S had a better quality part. Next, I printed this truck tire out of TPU designed by Elmcom 193290 on printables. Since TPU can be stringy, I dried the spool of TPU in my Sunlu filament dryer at 55 degrees C for 6 hours. The TPU truck tire turned out great from both the P1S and the S1. I couldn't find any real differences between the two printers' parts. Okay, now let's step up our game with a more challenging material, ABS. ABS can be a challenge because it tends to easily warp when printing because it really needs a warm environment. I decided to print this vice grips tool designed by 3dprintedhardware.com. I did use a brim and support because there was a lot of overhangs and some of the parts did not have much contact with the build plate. I was really happy with the results from both the P1S and the Kobra S1 because both vice grips turned out beautiful. Both wrenches did not have any warping and they both work really well. Once again, I couldn't see a difference in the quality between the two printers. Even though I'm not a big fan of multicolor printing due to the amount of wasted filament and how slow the prints take, since both the S1 and the P1S have multi-filament capabilities, I had to try a multicolor print. I printed this articulated Rexagon Trex plus Dragon Flexi by Pinky Wings on MakerWorld in 3 colors of PLA. The P1S took 6 hours to print and the S1 took 8 hours and 47 minutes to print, and they both created a lot of filament waste. I was curious to see why the S1 took so much longer to print the same model. I noticed the maximum volumetric speed for the S1 for PLA was only 12 cubic millimeters per second, versus the Bambu Lab maximum volumetric speed for PLA was 21 cubic millimeters per second. I'm not sure why the S1 volumetric speed is so low, but I will need to perform some additional tests to see how much I can increase it. Both prints turned out well, and all the joints easily moved. I couldn't really tell a difference in the quality of both parts. So, to summarize the parts quality section of this video, based on my experience, the AnyCubic S1 rivals the high quality printed parts from the P1S. There may be a few slight differences in print quality, especially with the PETG parts, but overall, I really can't say I see any significant differences between the print quality of the two printers. Now, let's compare the main features of the Kobra S1 and the Bambu Lab P1S. The Kobra S1 combo has slightly larger overall printer dimensions of 400 millimeters wide by 410 millimeters deep by 710 millimeters high, versus the P1S combo dimensions of 389 millimeters wide by 420 millimeters deep by 700 millimeters high. The Kobra S weighs 18 kilograms versus the P1S weighs 14 kilograms. The Kobra S1 has a smaller print volume of 250 millimeters cubed versus the P1S print volume of 256 millimeters cubed. They are both fully enclosed Core XY printers. They both have rigid internal frames and plastic panels. However, the Kobra S1 has a plastic top panel and door, and the P1S has a glass top and glass door. The Kobra S1 has a maximum hot end temperature of 320 degrees C, while the P1S has a maximum hot end temperature of 300 degrees C, so 20 degrees lower. The Kobra S1 has a maximum build plate temperature of 120 degrees C. However, the P1S has a maximum build plate temperature of 100 degrees C, 20 degrees lower. The Kobra S1 has a maximum speed of 600 millimeters per second versus the P1S has a maximum speed of 500 millimeters per second. They both have the same maximum acceleration of 20,000 millimeters per second squared. They both have a filament runout sensor and chamber fan with a carbon filter. Both have a nozzle wipe feature. The P1S has a multicolor filament, multi-material capability when using the Bambu Lab AMS, or Automated Material System Unit, and they can take advantage of the Bambu Lab RFID tags in the Bambu filament spools that allow the AMS to recognize the color and the amount of specific materials on each spool. Each AMS unit can hold 4 spools of filament, and you can connect as many as 4 AMS units to the printer for a maximum of 16 colors. The Kobra S1 also has a multicolor filament multi-material capability, which is called the ACE Pro, or AnyCubic Color Engine Pro. It also recognizes AnyCubic filaments that have RFID tags. Each ACE Pro can hold 4 spools of filament, and you can connect 2 ACE Pros to the printer for a maximum of 8 colors. The ACE Pro has a heater that allows you to dry your filaments with or without the printer printing parts. The P1S has the option for a heater in the latest version of Bambu Labs AMS system called the AMS2 Pro. Both come with an auxiliary parts cooling fan and a textured PEI build plate. The P1S works with the Bambu Studio slicer and phone app, the Handy, while the Kobra S1 works with their AnyCubic slicer, which is a fork of Orca slicer, and their phone app. Both printers print wirelessly using their slicers. They both have auto bed leveling, Z-axis offset, power loss recovery, and an internal LED light. Both printers can print in LAN mode. You can print the following filaments on both printers: PLA, PETG, TPU, ABS, and ASA. If you install a hardened steel extruder and hot end on the P1S, you can also print carbon-filled or glass-filled materials. However, the Kobra S1 does not have this option. The Kobra S1 has a 4.3-inch color touchscreen. However, the P1S has a 2.7-inch mono display to communicate to the printer. The P1S has a 720p low-resolution camera, and the S1 has a 420p low-resolution camera. You can transfer files using a micro SD card for the P1S and a USB drive for the Kobra S1. The Kobra S1 has spaghetti detection, however the P1S does not have this feature. Now let's compare the unboxing and setup. Both printers have similar unboxing instructions. If you are interested in my detailed unboxing and setup of my P1S, I have a link for that video in the description below. For the Kobra S1, it's just as easy to set up as the P1S. Once you remove the Kobra S1 from the box, it's just a matter of removing the various foam packaging from the printer and the accessory box. First, remove the 2 screws that are holding the ACE Pro and remove it from the top of the printer. Then remove the accessory box and more internal foam. Then loosen 4 screws and remove the ACE Pro holder from the printer. Next, cut the cable tie and remove the cardboard from the tool head. Remove 3 screws holding the build plate to the printer. The accessory box has the filament adapter, power cord, spool holder, a bag of activated carbon, tools, and lubricant. Attach the external filament holder to the back of the printer. Place the ACE Pro on top of the printer. Plug the 6-pin end of the signal cable into the ACE Pro and the other 4-pin end into the printer. Attach the filament adapter to the back of the printer. Attach the 4 PTFE tubes, inserting one end into the ports of the ACE Pro and the other end into the filament adapter. Attach the power cords and plug them into an electrical outlet and turn on the printer and the ACE Pro unit. Install the activated carbon into the inside back of the printer. Follow the screen prompts by choosing a language, region, and then install the AnyCubic app on your phone. Connect to your Wi-Fi, install the USB drive, and perform input shaping and bed leveling. Then load some filament into the ACE Pro unit. I also loaded AnyCubic slicer software on my computer using their supplied USB drive. Finally, I was ready to print my first part. Now, let's compare the cost of the 2 printers. At the making of this video, July of 2025, Bambu Lab P1S without the AMS unit is currently on sale for $549, normally $699. The P1S with the AMS unit is on sale for $749, normally $949. The P1S with the new AMS2 Pro is on sale for $869, normally $1,148. The AnyCubic Kobra S1 without their ACE Pro is currently on sale for $449, normally $549. The Kobra S1 with their Ace Pro is on sale for $599, normally $749. I think the best comparison is to compare the price of the P1S with the AMS2 Pro at $869 to the Kobra S1 with the Ace Pro at $599. So the Kobra S1 combo is $279 less. Let's go to my final summary and recommendations to see if spending the $279 less for the Kobra S1 combo is worth it versus buying a P1S combo. Overall, I am impressed with the quality of the prints I made on the AnyCubic Kobra S1, including prints made from ABS. And I consider the print quality to be comparable to the quality from the Bambu Lab P1S. So, you have to ask yourself if the additional $279 cost for the P1S is worth the different features of the two printers. Here's a brief summary of the features that are the same and that are different between the printers. Number 1, the P1S has a slightly larger print volume of 256 millimeters cubed versus the S1 print volume of 250 millimeters cubed. Number 2, both printers produced high-quality 3D printed parts. Number 3, the S1 has a slightly higher maximum speed of 600 millimeters per second versus the P1S maximum speed of 500 millimeters per second. Number 4, they both have the same maximum acceleration of 20,000 millimeters per second squared. Number 5, they both have filament runout sensors, nozzle wipers, auxiliary parts cooling fans, chamber carbon filters, filament cutters, auto bed leveling, and Z-axis offset. Number 6, the S1 has a maximum hot end temperature of 320 degrees C versus the P1S maximum temperature of 300 degrees C. Number 7, the S1 has a maximum build plate temperature of 120 degrees C versus the P1S maximum build plate temperature of 100 degrees C. Number 8, both printers can print a variety of materials such as PLA, PETG, TPU, ABS, and ASA. However, the P1S, with a hardened steel upgrade, can print carbon and glass-filled polymers. The S1 only ships with a brass nozzle, and there are no upgrades available. Number 9, both printers have low-resolution cameras. The P1S has a 720p and the S1 has a 420p. Number 10, both printers have multicolor, multi-material capability if the AMS or Ace Pro is purchased. In addition, both printers can dry the filaments. However, the S1 allows you to dry filaments while you are printing, but the P1S only allows you to dry the filament when the printer is not printing. So I would give a slight edge to the S1. Number 11, the 4.3-inch color touchscreen of the S1 is much better than the 2.7-inch mono scroll screen of the P1S. In fact, the P1S screen is the biggest complaints I've seen about the P1S. Number 12, the S1 has a quick change, no tools needed nozzle swap option, while the P1S requires you to take apart the tool head, including disconnecting several wires. On the other hand, the S1 only offers a 0.4 millimeter diameter nozzle versus the P1S offers 0.2, 0.4, 0.6, and 0.8 diameter nozzles, including some hardened steel options. Number 13, another important difference is the price. At $599 for the Kobra S1, it is $279 cheaper than the P1S at $869. Overall, I think the AnyCubic Kobra S1 is a worthy competitor to the Bambu Lab P1S. Just like with other Bambu Lab competitors, the Kobra S1 has closed the gap between them and Bambu Lab. I still think Bambu Lab is at the top of the list regarding their overall 3D printer hardware, software, and overall ecosystem offerings. However, printers such as the AnyCubic Kobra S1 offer an alternative consideration, especially for somebody who has a tighter budget. What do you think? Which of these two printers would you buy? Let me know in the comments below. If you'd like to see my video titled Elegoo Centauri Carbon Printer, better value than Bambu Lab P1S? That link is here. If you'd like to see my video titled Qt Plus 4 3D Printer, better value than Bambu Lab X1C? That link is here. Thanks for watching. Bye!